Okay, so we have our model. It has a number of parameters called these constants that in any specific situation, we're going to want to figure out. But at this point, it's easiest to solve it with all of these constants just left as they are. And that way, when we get to a new problem, we don't have to like resolve it. All right, looking at our differential equation, so we see that looking at ds dt and s, we see that this guy is both separable and linear. So we can solve it either way. Just so that we get some practice in, let's solve it as a linear dE. So to put it into the standard format where we see ds dt, we see s on the same side and everything else on the other side. If we look at this, we see that our functions k and k t naught are just constants. And so solutions here are going to exist and are unique for all real values. Okay, so that's good to know. We're going to build our integrating factor. U of t is going to be equal to e to the integral k dt, which is e to the kt. And we're going to multiply both sides by this integrating factor. On the left, we have a product rule derivative of s times e to the kt. And on the right, we have k times e to the kt times t naught. All right, we're going to integrate both sides, and we get s e to the kt equals this integral e to the kt times t naught. We can do that integral using a little u substitution. Alpha, let's call it u equals kt. So du is k dt. And so that makes this e to the u times t naught dt. Or e to the u t naught. Okay. When we do this integral, we also have plus c that goes along. And then we're going to solve for our temperature S. So S here is equal to T naught plus C over e to the kt. All right, and so this is the format of what our solutions are going to look like. Next up, we're going to let's see. One thing we can think about is what should happen over time. So if we look at the limit of these as t goes to infinity, we started with something that was either hot or cold. When we take a look at this, t naught plus c over e to the kt. Remember, k here was a positive value, and so e to the kt is going to go to infinity, and so c over e to the kt goes to 0. So over time, our solutions approach room temperature, which we know from experience should be the case. Okay. Next, we're going to apply this to a specific example of lasagna heating on the counter.